Ladies, gentlemen, non-binary and gender-fluid individuals, cyborgs, androids, interdimensional eldritch horrors, and 1980s British TV icons Zippy, Bungle, and George, welcome to the Crushing Deep. Imagine for a moment that you've modelled some intricate design for a close-up shot in a film or still image or a cutscene in a game, but then you only need it in the background thereafter and the dense geometry is killing your performance. Or maybe you need a normal map for design, but you can't find one like you're looking for, and all the online advice you can find for making normal maps for yourself just shows you how to convert an existing 2D image into a normal map, and you, like me, just aren't that good at working with two-dimensional mediums. Well, for these instances and more, I'm going to show you a quick and easy way to convert any existing three-dimensional geometry into a normal map that will simulate the same geometry on a flat surface. I'm going to show you this method using Cinema 4D, but what's great about it is that the same basic process will work in literally any 3D modeling and rendering software. Before we get started, so as not to put off newbies, if you're really new to 3D modeling, you may not know what I'm talking about with normal maps. So very quickly, most 3D renderers will use one or both of two methods to give the illusion of modeled geometry on a flat surface through either a bump map or what's called a normal map. A bump map is a black and white image that uses brightness to convey depth. The brighter a pixel, the higher it is, and the darker, the lower. If we use this artwork by Kazuki Takamatsu and put in the bump channel of this material, and then apply it to this flat plane, we can see that the design comes through in the form of shadows, making it appear as though there is a relief embossed on the surface, even though the plane is still entirely flat. Many programs will use normal maps as well as or instead of bump maps because they use not just brightness but colour to indicate direction, allowing for more detail to come through. If you have a bump map for your design but need a normal map, you'll be able to make one easily by baking the bump map into a normal map in your rendering software, like you see here, to get even better results. If you just Google how to do that on whatever software you're using, you should find numerous tutorials, but if for whatever reason you can't get that working, the method I'm about to show you for making normals from geometry can also be used on planes with a bump map applied. So now that that's out of the way, let's get started on a simple setup. So let's start a new project, and we're first going to import the model we want to give the illusion is there on our flat surface. Now I've made this Art Deco relief that will be used in various places in the game I'm making, but it's just an unimportant background detail, so I don't need my game engine wasting processing power on that. So we're going to turn it into a normal map and apply that to a flat surface with only 4 points. Now I built this model with making this normal map in mind, but that may not be the case for you, so make sure you angle your model so that the perspective you want to create your normal map from is facing straight up. Next thing we want to do is create a new material. I'm not even going to bother naming this material because it's going to be the only one we use and it won't be in the final scene we use our normal map in. So in this material, I'm leaving the color as default in Cinema 4D, but if your software gives a different default color, set it to a light gray or off-white and then turn off any other active channels. We want this to be as neutral and blank a canvas as possible. And now we're going to apply that material to our model. Next, we're going to add a light to the scene. It's going to be dead center on both the horizontal axes and 1000 centimeters up on the vertical axes. We're going to make sure shadows are off and set the color to 128, 128, 255 on the RGB scale, or 0.5, 0.51 if your software measures color that way. Your model should now be washed in this delightful bluish purple color. Now, copy and paste the light, but lower it down to 100 centimeters high, and I've noticed different programs label their axes differently, so we're going to set the coordinates to 1000 centimeters in the forwards-backwards axis, and minus 1000 centimeters in the left-right axis, so that if you look from above, the light is off to the top left. Now we're going to change the color of the light to 128, 255, 255, or 0.51, 1, so that all the sides of your geometry facing that light now have a teal highlight. Now copy and paste that light again and set the coordinates to 1000 centimeters in the forward backwards axis and 1000 centimeters in the left right axis, so that if you look at it from above, the light is off to the top right. Now we're going to change the color of the light to 255 128 255 or 10.51, so that all the sides of your geometry facing that light now have a pink highlight. Now copy and paste that light again and set the coordinates to -1000 in the forwards backwards axis and 1000 centimeters in the left right axis, so that if you look from above, the light is off to the bottom right. Change the color of the light to 255 255 or 101, so that all the sides of your geometry facing that way now have a reddish purple highlight. Finally, copy and paste again, making a fifth light. Set the coordinates to -1000 centimeters in the forwards backwards axis and -1000 centimeters in the left right axis, so that if you look from above, the light is off to the bottom left. Change the color of the light to 00255 or 001, so that all the sides of your geometry facing that way now have a deep blue highlight. Next, create camera and position it above your object, pointing straight down. You should now have an object where flat surfaces show the lilac color of our first light. Surfaces facing top left should be teal, those facing top right pink, bottom right deep purple, and bottom left blue. If you don't see this, don't fear, it's probably the scale of your object versus the dimensions I gave you. Obviously, the positioning of the lights assumes your object has the same dimensions as mine, which it might not. So to fix that, create a null object at the very center of your scene, drag and drop all of your lights into that null object and rename it normal lighting or something similar. You can now rescale that null object to increase or decrease the size of your lighting setup on all axes independently or all together, without having to do it for each individual light. Play around until all of the lights are positioned where they need to be to light your object as described, and don't forget you can also reposition and scale your object as well. Next, set up your renderer so that your object takes up as much space in the render as it can without spilling over the edge, and render out your normal map. You can use this rendered image as a texture in the normal channel of your finished scene. Make sure to save the normal map lighting setup as well, and then you can reuse this at any time you need to make a normal map. And as I said, this works for converting bump maps too, if for whatever reason you're unable to bake them. What I also did here, it was render another pass with the lights turned off and a material applied that had only the luminance channel switched on to create an alpha mask for this plane. As complex as this looks, it's a single polygon with two textures in its material. I hope this was helpful to you, and I'll talk to you next time. Goodbye.